In this video, we'll study Module 3 Fluid Dynamics. Our concept is Euler's equation of motion. See, this Euler's equation of motion is very interesting and important concept in fluid dynamics. See, we'll see what is Euler's equation. Euler's equation of motion for a steady flow is an ideal fluid along a streamline. It gives the relationship between velocity, pressure, density of moving fluid. Okay, then this Euler's equation of motion is based on Newton's second law of motion. Before going to start the derivation on Euler's equation of motion, we'll see what are the assumptions are involved in the Euler's equation of motion. See, the first assumption is fluid is said to be ideal. That means the viscosity of the fluid is 0. Flow is incompressible and steady flow. Then there is no energy or force is considered, but effect of gravity and pressure force is involved in the flow. Then there are certain limitations for Euler's equation of motion, that is, in actual practice fluid is not ideal and velocity is fixed to the boundaries, and in practical situation viscous force are involved, but as per the assumptions we neglected the effect. See, this is a major limitations of Euler's equation. And some energy addition or subtraction may take place as the fluid changes from section 1 to section 2, but we considered in the assumption there is no energy or force is considered. See, these are the major limitations of Euler's equation of motion. See, the applications of Euler's equations or Bernoulli's equations are Venturi meter, orifice meter, pitot tube, pitot static tube, notches and nozzle meter. Okay, the derivation of Euler's equation of motion. See, now we'll see what is Euler's equation of motion derivation as well as how to obtain the Bernoulli's equation from the Euler's equation of motion. The equation is derived by considering the flow in S direction, and flow is steady and streamline. See, from the figure we'll consider the forces acting on the cylindrical element. So the first one is at the section 1 pressure force acting on the directions of the flow at the section 1 area is dA. Similarly, at the section 2 pressure force in the opposite direction of flow, that is P into dou P by dou S into ds into area dA, area that is elemental area. Then weight of the fluid in the downward direction, that is rho g dA ds. Then theta. Theta is the angle made between the flow of a line of action of the weight element. Then we know that the Euler's equation of motion is based on the Newton's second law of motion. Therefore, that is the resultant force on the fluid element is equal to the mass of the fluid element and acceleration in S direction, that is F is equal to ma. Therefore, we need to write the forces acting on the fluid element based on the direction, that is PdA. Then in the opposite direction, that is minus P plus dou P by dou S into ds into area dA. Then minus, see here minus, that is for weight in the downward direction, that is minus rho g dA into ds cos theta. Now you can ask why it is cos theta. You can observe in the diagram there is we are going to resolving the forces that is in a horizontal and that is a vertical, that is cos theta and sin theta. The any component which is away from the element is neglected, therefore we neglected the sin theta, we considered cos theta. is equal to mass into acceleration. That is rho into dA ds the mass, then acceleration in this direction is as, where as is nothing but acceleration in s direction. Therefore, we know that acceleration is nothing but rate of change of velocity with respect to time. Here the velocity is a function of s and t, the direction s and the time t. Therefore, differentiating the acceleration equation, but the velocity is a function of s and t. Therefore, that is dou v by dou s into ds by dt plus dou v by dou t, because velocity is a function of s and t, we differentiated partially. Then we know that dou v by dou t is nothing but rate of change of velocity with respect, dou s by dou t is nothing but rate of change of distance with respect to time, that is nothing but velocity. Then dou v by dou t, that is rate of change of velocity with respect to time, but we consider the steady flow, therefore dou v by dou t is equal to 0. Then acceleration in a s direction becomes v into dou v by dou s. Then from the equation 1 we need to substitute the value of acceleration in s directions. Therefore the equation becomes that pda becomes cancelled, then minus dou p by dou s into dou s dou a, sorry, there is not a dou s and dou a, that is ds and da, minus weight in downward direction, that is rho g da ds cos theta is equal to rho da ds, substituting the value of acceleration in s direction, that is v into dou v by dou s. Then now dividing the above equation by rho ds da. Therefore after the dividing we are going to get dou p by rho into dou s plus g cos theta plus v dou v by dou s is equal to 0. But from the figure you can observe what is cos theta, that is cos theta is equal to dou z by dou s. Therefore substituting the value of cos theta, that is dou z by dou s, and equal to 0, that is we are going to take 1 by rho as a can take 1 by rho as the separate, then rho dou p by dou s plus g dou z by dou s plus v dou v by dou s is equal to 0. Therefore the above equation can be rewritten as dou p by rho plus g into dou z plus v into dou v is equal to 0. Then call it as a equation 2. The equation 2 is called as Euler's equation of motion. Then with the help of this Euler's equation we can derive the Bernoulli's equation by integrating the equation 2 and equate it to constant. Therefore on integrating the equation 2 we get integration of dou p by rho is p by rho, then integration of g dou z is gz, then integration of v with respect to v is v square by 2 is equal to constant. Then by dividing by g we get p by rho g plus z plus v square by 2g is equal to constant. The above equation 3 is called as Bernoulli's equation of motion, where the terms involved are p by rho g plus v square by 2g plus z, where p by rho g is called as pressure head, then v square by 2g is called as velocity head or kinetic head, and z is called as potential head. Therefore we can easily state the Bernoulli's equation statement is the sum of the pressure head velocity head and potential head